In today's lesson, we are going to be looking at going from graphs to equations for our sinusoidal functions. So in the previous lesson, we looked at kind of the characteristics of sinusoidal functions and how to um, graph them according to what the equation was. So we looked at the a, the k, the c, and the d value, and we're able to kind of determine how that changed our main or our base functions. So if we look at the two formulas, they're all the same, except the only difference between the two is one is sine and one is cosine. Right? We talked about those two different ways. Those are the kind of two sinusoidal functions that we looked at. And of the two, again, they have the same letters, the a, the k, x, or sorry, a, k, c, and d. And a told us the amplitude. So it doesn't matter which one we were looking at. The variables still mean the same thing. So A tells us the amplitude, right? This is from the midline to the max or minimum, right? So our midline to the max or min, or half the distance from the max to the min. K tells us how many cycles per 360 degrees. Right? So how many cycles there are going to be of our wave for every 360 degrees. And there was a way to tell as well using the k value how long our period was. And in this case, it was 360 divided by k equals our period or the period length. So again, that's going to tell us how long each cycle is. C, so C tells us whether it's a phase shift or a shift left or right. And it's going to be the opposite of what we see. And again, the reason for that, we have our general function here. And if we can see in general, there's already a minus. It's already minus c. So if I'm moving left, I would technically have a negative value, or I'd be subtracting to go left or more negative. But when I subtract a negative, it becomes a positive. Right? So that's why it appears different in the actual formula, because the way the formula is set up, there's already a minus there to begin with. So if it's a positive or moving to the right, we would see minus a positive value, which is just a minus. And if it was moving to the left, like we said, minus a negative is positive. And the last value, d, tells us whether our phase shift up or down. And in other words, it tells us what our midline is. Right? And again, this we take exactly as we see it. If it's a minus value at the end, it means going down. Positive, going up. So the only ones that we use opposite of kind of what we see are the C value and the K value if we're trying to determine the changes to the actual values. But the nice thing about going from the graph to the equation is that I don't need to really worry about that too much. I just need to use this information here to kind of pick out the values from our actual graph. So again, we have our values here. We have, or not our values, our base functions, right? We have our sine wave on the left, our cosine wave on the right. We can see our amplitude, the period. We can look for our key points again if we want, because it is helpful to find that, especially our max and our min, as well as our midline points. But as we can find our max and our min, then generally we should be able to know where our midline values are going to be, because we know it has to be halfway between them. And same thing with where it's located, right? If I know that my max is here, my min is here, then the midline point needs to be halfway between those two, both horizontally and vertically. So it is a nice kind of nice things to look for. One thing to note, because we're going from a graph to an equation, there might not be an inherent form, right? What I mean by that is it might not be sine or cosine, right? We don't know which one it might be, so it might be ambiguous. And we know that term before, like from our ambiguous case with the sine law. And again, just meaning we don't know which one it could be, right? Unless we're told specifically. But if we look at these two, there's similarities between them, right? I can find my sine wave in the cosine wave right there. That's my sine wave. I could also find it maybe if it was flipped, right? Negative or flipped, there's a sine wave. Same with if I look at the sine wave, I can find the cosine wave. There's the cosine wave. It's shifted over to the right. Everything else stays the same, right? Here it is again. So we could use either a sine or cosine to come up with our equation. It doesn't, unless we're told specifically, we can use either. Now, there may be some that are inherently easier to use than others, right? Generally speaking, if we look for the starting value, generally if it starts at the midline, it's probably easier to use sine. If it starts at a maximum or a minimum, because it's flipped, cosine might be better. But again, you could use either, right? So you can use either cosine or sine to describe sinusoidal functions. So you can use sine or cosine to describe sinusoidal functions. So we're going to look through a couple of examples. We'll do one for each. So these two right here, there is one that is probably easier to use than the other. And then our last two, we will come up with both examples, both using sine and cosine. Right, so it is going to be helpful to have an idea of what our original function is. So again, having those notes, having a good idea of that main sine wave will be helpful to coming up with these equations, because we want to look and see where or how the values have changed. So if I look at the first one here, I'm going to go through and label some nice points. Specifically, my max and my min. And it does work out that I can clearly see where my midline is going to be. I have my max and my min. My midline is going to occur there. And from there, now I can also find the amplitude. Right, so the amplitude is this height. So going from from 5 to 7, that's a change of 2, or that's an amplitude of 2. And same thing the other way, going from 3 to 5, that's also a height of 2. So I know my amplitude. My midline I know is at 5. The other thing we're looking for is our period. So in this case, I see the start here, I see the end here. That is a distance of 180. So I can use that to help me find what my K value is. Or we could look at it and already tell, right? Because we have two sine waves in 360 degrees, that means K has to be 2. If not, I can use the quick formula, P equals 360 over K. 180 equals 360 over K. And then we get that K is equal to 2. So you might have to do a small calculation for that. But in other cases, you might just be able to look at it and see, okay, how many periods are there per 360? So I'm going to go through and start writing out my equation. I'm going to use the sine function for this one because I can see that my starting point, or the point that's at 0, or when x is 0, is a midline. Right? So I'm going to use my sine function. You could use cosine as well, but I'm going to use the sine function for this one. So the first number in my sine function has to be my amplitude, or my A value. So right now I know there's a 2 because my amplitude is 2. Now I have to also check, is there a flip? Right? Has my sine wave flipped from the original? Well, our original sine wave is supposed to move up, go up to a maximum, and then come back and go down to a minimum. This one starts off by going low and then high. So that means there is a flip. So I can use -2 for my A value. I'm going to have sine. Now I need my K value, which I already predetermined was 2 because there are 2 sine waves per 360. Is there a phase shift left or right? No, in this case, there's not, because we can see we're starting here. Again, depending on what you call your starting value, because our our sine wave kind of repeats over and over again, maybe we could say that, oh no, this is actually the starting value and we've moved it over 90, right? In this case, just always refer to the first point as you're starting. Has that changed? And in this case, no, it hasn't. So there is no phase shift left or right. And then we have to check to see, is there a phase shift up or down, right? And we can tell that from our midline, which is a positive 5. So we've moved our graph up 5. And that's our equation. Right, we're looking for those four values based off of what we see in our graph. If I look at the next one, again, I'm going to go through, highlight my points. Okay, I see one there, one there, one there, one there. So based off of that, we could, and then again, I can see where the midline is. If we don't, let's check. It has to be half this distance. So in this case, we go from 1 to -5. So that's a change of 6. So my midline should be at 3, or I can say -5 minus, -5 minus 1 is -6 divided by 2, and find the answer, or and then go from there. So I can see now, I can see the midline points here. So that will help me when I go back. I'm going to draw my midline across. I can find my amplitude, right? It would have been half that distance, or half of 6. In this case, it is 3 from 2 to 1, or -2 to 1, or from -2 to 5. The amplitude, the A value, is always going to be positive. We only put the negative if it's flipped. And the other thing we want to do is we want to check for our period. We want to see how far or how long is our period, or how long is one cycle. So we start here, and when we come back to there, we end up over here. So this is our period. That's our length. And we will find that this is 240. So using our formula, P equals 360 over K, 240 equals 360 over K, we get that K is equal to 3 over 2, or 1/2. So basically we're getting 1.5 cycles per 360 degrees, which we can see, right? We can see 1 and then 1/2. So we can see that visually as well. So we're going to write our function usually in terms of, I'll put in -2, just put in red. Usually in terms of the phase shift left or right, we usually have to first see what type of function are we looking at, sine or cosine. Because our starting value is not the midline, I'm going to say let's use our cosine function for this one. So I'm going to at least put 3 down for my cosine function, for my amplitude. Now I have to determine, is this flipped or not? And you remember, for our cosine function, we start off at our maximum and then come down, which in this case we can see as well. We're starting off high and then we're coming down. So it's going to be a positive. There is no flip. So it'll be 3 cosine, our K value, which is 3 over 2, X. Is there a phase shift left or right? Well, again, let's see, our maximum in our cosine in the basic function was starting at when X is 0, which in this case it does as well. So there is no shift left or right. Then our last value is our midline. In this case, it is -2. We shifted down 2. And that is our cosine function for this sinusoidal wave. Only 2 more, but for these 2, let's try to come up with both the sine and the cosine version for this graph. So we're going to go through and find those key points again. So we can see our max and our min. We can find our midline halfway through. We put points there. I'm going to draw the line in as well. So this line is at 0.5. We can find our amplitude, which in this case is from 0.5 to 2, or 1.5, or from 0.5 down to -1, which is 1.5 as well. We want to find our period. So in this case, our period would be from here all the way over to here. So again, this one is 240 again. So again, we can go through and do the formula 360 over K. 240 equals 360 over K, and K equals 3 over 2, or 1.5, which is the same as the last one. So that's why I kind of just breezed through that quickly. Now, we have enough information to go through and come up with one of our sine waves, or our functions or equations. Looking at our first starting point, it is our maximum. So in this case, the maximum means we probably should start off with cosine, right? The cosine wave starts off at the maximum and goes down. So let's start with that. We have our A value of 1.5. I don't need to make it negative because, again, as we just mentioned, our basic cosine wave starts off at our maximum and goes down, which this one does. So I don't need to worry about flipping anything. So 1.5, or you could say 3 over 2. Again, whichever you prefer. We'll just say 1.5. So 1.5 cosine. And then we need our K value, 3 over 2 x. Have we moved it left or right? Well, no, because our starting point is at when x is 0, which is what we want for the sine or cosine wave. And then our amplitude plus 0.5, or sorry, our midline of 0.5. So you want to be careful. You want to make sure you're looking at the scale to help determine what the actual values are. Don't just count the squares. So that's our cosine wave. Now, if we wanted to do this as a sine wave, all the values are going to roughly stay the same. The only difference is going to be is we want to find out where is our first midline point. So if I start at my peak here, which we've attributed to a cosine function, my first midline point going to the right is here. So I'm going to pretend that that is my first point in a sine wave. So I'm going to use that as my reference to compare to the original sine wave function. Now, most of the values are going to stay the same. The A value is still 1.5. That hasn't changed. It's now going to be sine. The period is still going to be the same, even though we've moved over. If I look at going from here to where do we come back to our midline after going up and down over here, that's still 240 degrees, right? So that hasn't changed. That's still the same. So it's still going to be 3 over 2 for our K value. And it's still going to be a plus 0.5 for our midline. Now, I did leave a space because, I already know what the answer is, but we have to look for two things. Our midline for our cosine wave, or for our sine wave, the starting value usually starts at 0, right? It's usually when x is 0. It's usually over here somewhere. We've already attributed the moving up to the plus 0.5, but we haven't talked about the shift to the right. So usually this starting point is over on the y-axis, but it's moved to the right 60. So to account for that, I have to put a minus 60 in with the x. And again, the reason that it's minus is because in our base function, or our general function for transformations, it was x minus our c value. So if it's a positive, x minus a positive is a negative. The other thing is, does our sine wave start by going down and then up, or up and then down? If you go back to your notes or go back to the beginning of the video when we looked at the example, the sine wave usually starts going up and then down. But this one, if this is my starting point, this goes down and then up. So it's flipped. So that means I need to put a negative with my amplitude to indicate that it's been flipped. So looking at the comparison between these two, we see a difference in there is a C value and in our negative. We're going to keep that in mind when we move on to the next one. But again, these two different functions will give us the same sine wave. Right? And realistically, if you were to graph a sine wave, it might look almost identical anyways, because most graphing calculators might show you the fact that it just continues on forever. You would have to put restrictions in and say you only want it from 0 to 360. Because if we saw the entire thing, it keeps on going forever in both directions. So looking at the next one, again, same idea. Let's go through and find our key points, our maximum, our minimums. Those are relatively straightforward. Not as easy to find our midpoints, but we know where it has to be, right? If our entire distance from here to here, from 3 to -1, that's a change of, or that's a distance of 4. So my midline needs to be 2 up or down from each one. So -1 plus 2, that brings me to 1. 3 minus 2 to come down, that brings me to 1. So my midline is here. That also helps me find the nice points where our line crosses, or where our other points are. And generally speaking, they usually will end up with nice values, because this will end up actually being halfway between 30 and 60. I can now also put out my amplitude. So from 1 to 3 is 2, or from 1 to -1 is also 2. And our period, we start here and we repeat to here, that's 180 degrees. So one small little calculation beforehand, I want to use that P equals 360 divided by K. 180 equals 360 over K. K equals 2. K equals 2, which makes sense because I have 2 cycles per 360 degrees. Now we need to go through and figure out what our equations are. And again, with this one, because we're starting at a minimum, I'm going to start with my first one with cosine. Right? So cosine would be the easier one to start with because of what our first value is, or what the value along the y-axis is. Right? It's a maximum, so I'm going to, or a minimum, sorry, in this case, so I'm going to use cosine law. Or not law, sorry, I'm getting it all mixed up. I'm going to use the cosine function. So I can put in my amplitude of 2. I can put in my k value of 2x. It hasn't shifted left or right because, again, this value, we do want it to start on the y-axis, which it does. And we can say +1 because of the midline. Now, the other thing, kind of mentioned it before, or kind of talked about it briefly, our cosine wave is supposed to start at a maximum and go down to a minimum. This one starts at a minimum and goes to a maximum. That means that this has been flipped. So I'm going to put a negative in front of that 2 to indicate the flip. So the negative for the flip, 2 for the amplitude, and the 2 here because we have 2 cycles per 360, and the +1 because we've moved up 1. Now I can also, like I did in the last one, use a sine wave to represent this, or a sine function to represent this periodic function. Most of the values are going to stay the same. I'm going to leave the 2 for the amplitude. I'm going to put sine instead, 2 for the period, because again, if I look at a sine wave, it should start here. Right? I'm going to the first point on the midline and end here. That is also 180 degrees still. I'm going to leave a space, and I'm still going to put the +1 because of the midline. Now, the two things that we need to think about. One, has this point moved from the y-axis? Yes, it has. Right? We go back to our basic sine wave. It should be on the y-axis. This one is not. It is actually moved over, and is moved over to the right 45 degrees. So I'm going to put minus 45 for my C value. The other thing is that I want to check is this flipped? Well, for a sine wave, we want to start at a midline and go up, and then come back down, and then go back to our midline. So in this case, this does match our sine wave in terms of the direction it's going. That means it is not flipped, so I do not need to put a negative in front of the 2. So comparing it to the cosine function, the only things that I changed are the C value and the A value. And by the A value, I mean just the sine. Right? So if you're going from the cosine to the sine wave, you're going to have to change the C value and make sure that it is flipped or the opposite of whatever your cosine wave is. Right, so these two functions, or these functions for both of them, will give us the same graph, just in a different function. Right, one's sine, one's cosine, but it should be this. It should give us the same thing. So that is the key, or that is it for this lesson. Again, it's taking what we learned in the previous lesson and using that to find the information so that we can work backwards to come up with an equation. Right? This one might be a little bit more applicable because we might find a sine wave, or we might see waves, and we want to come up with an equation to approximate it, that type of thing. So it might be more common to go from a graph to an equation than from an equation to a graph. Maybe we do need to change if we an equation, and that's where the previous lesson would come into play, because we want to know how these values change. But again, for this lesson, focusing on going from the graph to the equation, using those same values, and understanding that for any sinusoidal function or graph, we could come up with cosine or sine, or we could represent it as sine or cosine.